Good morning, this is your Stat Sensei, Mr. Spensei, and this is a scenario on online dropouts. And we are looking at one sample proportions, and we're going to break down some conditions. Previously, we ran this entire test, so if you want to see that, go to the day before and you can see the entire test. But right now, we're going to talk about the conditions because we didn't discuss that when we ran the test. So, online dropouts. With the rise of online education, more and more students are opting to take courses remotely. However, one of the biggest challenges faced by online educators is keeping students engaged and ensuring they complete their courses. Research suggests that 85% of students enrolled in online courses complete them successfully. So, our null hypothesis is P equals 85% because that's what the research says, that's the claim. However, the director of an online university, Dr. Martinez, is concerned that the completion rate at his university is lower than the national average. So basically, we have an HA where we're going to say, hey, you know what? We believe that it's lower than 0.85. That less than came from that lower. Dr. Martinez knows that many students drop out or fail to finish their courses for various reasons, including lack of motivation and because of the flexibility of self paced learning. To assess the situation, he took a random sample. Hey, that's important. That's a condition of 120. So we have a sample size of 120 out of the more than 1,500. Oh, we have a population size of 1,500 who enrolled in an online course over the past semester. Out of those students, 100 completed the course. So this right here is my X value. 100 out of 120 successfully completed the course. Dr. Martinez wants to test to see if the completion rate is significantly lower. We've already discussed that. That's the alternative. All right. So at an alpha equals 5%, does Dr. Martinez's university have a lower online completion rate than the national average? So in this case, we have X of 100 over an N of 120. And when we divide that out, we can get our P hat. So 100 divided by 120 is 0.833. So there's our P hat. And they gave us the population claim of 85%. So the very first thing we're going to be asked to do is do the conditions for a hypothesis test. Well, the conditions for a hypothesis test, first off, we need to look at the formula. So Z equals P hat minus P over P times 1 minus P over N. Now, if you'll notice, we have the population proportion in the standard down here. That's going to be very important because we're going to need to keep that in mind when we're running our conditions. The first thing, oh, random sample, they told us that. They said that in there, and it was a sample size of 120. That was given. We just checked that off. That's good. All right, the sample size. Well, our sample size is 120. We always multiply by 10. 120 times 10 is 1,200. That's less than 1,500, which was our population size. So this right here is our pop. And so N is less than 10% of the population. Yay, we're good there. This is where we need to pay attention to the formula. If we always look here, this will tell us what we're going to be using for our conditions. If we have a P in there, we're going to be using our P for condition. So our sample size times our population proportion. Well, our sample size is 120. 120 times 0.85 is 102. And we're always going to be comparing to 10 in this case. 120 times 0.85 is a 102. All right. And that's greater than 10. Now, please remember, here we're comparing to 10. When we were running t-tests and z-tests for means, it was 30. All right. But here for proportions, we're looking for it to be greater than 10. All right. So please pay attention to that. This is for proportions. So that takes care of the first one. We met there. We're good. Then we have to do it for 1 minus p. So 120 times 1 minus the 0.85 is 18. And 18 is greater than 10. So in this case, our sample is large enough. Okay. All right. That was the conditions for the hypothesis test. We're going to need to do the conditions for this confidence interval, and we'll notice a little bit of a difference. So create a 95% confidence interval for the proportion of online courses students at Dr. Martinez's universities complete. Well, random sample of 120 given. Hey, that's exactly what we had before. That didn't change. That's good. We had a sample size of 120. We always multiply by 10. We get 1,200. That's less than our population size of 1,500. So N is less than 10% of the population. Good there. But now we have a change. All right. And I'm not sure what happened here. When we get to the third one, we need to pay attention to what our we need to pay attention to our formula for a confidence interval. A formula for a confidence interval is p hat plus or minus z star p hat times 1 minus p hat over n. And if you'll notice, I have p hats. Up above, I had p zeros, but here I have p hats. Here I was using the population, but for the confidence intervals, I'm using the sample proportion. So I have to use the sample proportion here. So 120 times my sample proportion, and remember that was the 100 over the 120. And when I do that, 120 times 0.8333, I get about 99. And 99 is greater than 10. So that part's good. But then I have to check the 1 minus. And I have 120 parenthesis 1 minus 0.8333. And I get about 20. That's also greater than 10. And so in this case, the sample is large enough. Super important that you pay attention to those formulas. If you're running a confidence interval, you're going to use p hats. If you're running a hypothesis test, you're going to use p. So make sure that you pay very careful attention to make that adjustment. All right, I appreciate you watching, and I look forward to seeing you on the next one. Thank you.